So coating is added to improve surface properties. Such as friction, wear resistance, and anti-sticking behavior. So, but we have to also consider the intrinsic limitation related to the production of this coating material. For example, many coating processes might increase the temperature of a substrate during the growth of the external layer. So as we said, the minimum strength is required for our base material. So in many cases, this components undergoes heat treatment typically tempering at a low temperature. So this is the final stage for production of our base material. Now, if we expose our material to a higher temperature during the deposition, process, we can lose the original hardness or strength of our base material. So because if we pass the tempering temperature of our component, we have a decrease in mechanical strength. So the risk is to produce our coating and to reduce the strength of our base material. Then we have to select the process able to ensure a maximum deposition temperature not above the upper limit posed by the base material. We have to consider the thermostability of the base material. So we have to consider thermostability of the base material. So typically we combine a hard coating with a soft substrate. So this is a soft substrate this one is the soft substrate, excuse me. This one is the soft substrate and this one is the hard coating. So overall we have to combine a hard coating with a soft substrate. For PVD and CVD techniques, the thickness of a layer is not so large. The external load we applied during this service is supported by the substrate, and this problem is to be considered carefully, and we are going to see this problem in the upcoming lectures. So a good tribological performance often requires high levels of hardness and stiffness of the substrate material because the thickness of PVD and CVD coatings are limited. In addition, we know that many PVD techniques are line of sight methods. So if we have a complex shape of a cutting tool, then we have to perform a deposition process in a proper way in order to coat uniformly the total object surface. Even if we have cavities or steps, something like that. A basic requirement of our coating is to remain adherent to our substrate. So premature failure of our coating fragments must be avoided. Premature coating failure due to poor adhesion. Premature failure of coating, that is coating failure, is due to poor adhesion. To the substrate. We can call it as a cracking or spalling of the coating material, and it can be disastrous because loose coating fragments can aggravate the VO. So this process typically produces small fragments of our coating. So we produce small fragments over a very hard material in the contact region where components are exposed to large normal stresses. Then we create a three-body wear mechanism, which is very dangerous. So the premature coating failure is worse than the abscess of coating, and we have to avoid this process anyway. Finally, in the principle, when we combine different materials, we have to check the risk of galvanic corrosion. Typically, the base material is metallic, so we have in principle the risk, but fortunately, the most wear resistant material are ceramics. So they are not electrically conductive, and risk of galvanic corrosion is not so common. But in principle, we have to consider this aspect.